All right, good afternoon, everyone. My name is Gary Canter, and I'm a senior cloud engineer at Applied Research Associates. I've been in IT operations for about 10 years now, but over the last few years, my work has shifted more towards DevSecOps with a hybrid technical and leadership role. Today, we're going to talk about our team's experience with deploying and managing multiple air-gapped networks. We have a lot of government customers that expect a heavy focus on security, so we tried to automate as much as we can to make it easier for ourselves to deploy and maintain these air-gapped networks. I'm sure many of you are experienced with deploying and maintaining production networks. There might be even some of you that have experience with managing air-gapped networks, usually for compliance. They're usually not fun, but we've tried to make our jobs easier to automate by automating as much as we can. These challenges that we experience with single air-gapped networks compound when you start needing to scale out to multiple air-gapped networks. The time and labor needed to support grow exponentially to unsustainable levels in the long run. So what can you do to make this easier for yourselves? Well, we went with using a collection of services and technologies to automate as much as we can. We did this with a mixture of Amazon Web Services, Terraform for our infrastructure as code, and SaltStack for our configuration as code. Leveraging AWS as an infrastructure as a service provider, we're able to offload the maintenance of physical hardware so that our teams can spend more time creating value for our customers and implementing new features. Using Terraform, which is our infrastructure as code tool that we decided to go with, we are able to define our entire network as code and deploy these air-gapped networks across multiple AWS regions and fabrics, such as commercial or GovCloud. Once we've used Terraform to deploy our backend infrastructure, we're able to use a combination of SaltStack and group policy to automatically configure the security posture of our network. These can be things like our server applications that our developers need to use. Within AWS, we can create these virtual air-gapped networks using VPCs, firewalls, and other AWS services. Some firewalls even have Terraform providers so that you can configure your firewall rules and objects within code along with the rest of your network stack. Because we can define this entire network backbone as code, we can deploy these virtual air-gapped networks across multiple AWS regions and accounts, either per customer or for prototype staging and production environments. We decided to use Terraform for more than just our backend networking. We also use Terraform for deploying our server applications that our developers and customers need. These can be services such as GitLab or the Atlassian stack or even Jenkins, which has been mentioned a few times this show. Expanding on that, we can create CI/CD pipelines for our Terraform code so that when we push changes to our main branch, they get automatically deployed through our different fabrics, so prototype, staging, and production, and we can implement QA testing as part of that rollout. SaltStack, which is an agent-based configuration as code tool, can be deployed as part of your base operating system images so that when you go to deploy your servers, it will automatically configure them based on your code. As an example, if you deploy an EC2 instance with Terraform, you can give that instance a role of Confluence, and SaltStack will automatically install and configure Confluence based on your code. This lets us maintain or deploy the exact same application across multiple networks. Because your entire environment is defined in code, we can easily see the security posture of our network at any given time. This lets our team spend less time fighting fires and more time on implementing new features for our customers. As some examples, if you need to implement new security controls or patch and update your endpoints in your network, you can quickly update your CAC and enroll those changes out through your CI/CD pipelines into your multiple environments, hopefully starting with prototype. AWS even has some native security services that your team can leverage to reduce the overhead even further. Because these are AWS services, you can also configure them and deploy them with your same Terraform code. As some examples, GuardDuty, which can scan your network for anomalous or malicious activity, Inspector, which can scan your network for vulnerabilities, and CloudWatch and CloudTrail, which work together to aggregate logs for your EC2 instances and changes in your AWS account. So at a high level, that's what we did to try to make our lives a little easier. What can you do from here? Well, start small. Pick one of your server applications that you're hosting and deploy it using an ISC tool like Terraform. From there, install and configure it using a CAC tool like SaltStack. You'll be surprised at how fast and easy it is to implement new features for your customers once you have this strong technical baseline of code. That's all I have for today, but if you're interested to know more or to go into more details, you can find me in the hallway, and I will gladly talk your ear off. But thank you for your time.